Okay, so for this first example, write all your statements and reasons in first, your givens, and then mark your diagram with whatever you can mark. You should be able to put a couple markings on this. Okay, let me open it up to everybody now. What markings are you putting on your diagram? Just give me one pair of markings, please. One pair of markings. Shoot. Emma, one pair of markings.
I did that angle ABC is congruent, so I did like the arc marks on angle ABC and FG.
Good. Everyone should have arc marks on FGE and ABC. You should have another pair of markings somewhere in your diagram, kiddos. You should have another pair of markings somewhere on that diagram. 8. Ryan, where else do you have markings?
Line segment FG is it congruent to line segment BA?
How'd you get that?
Because it's perpendicular.
Perpendicular means congruent?
Oh, never mind.
Come on, you're better than that. What do perpendicular lines do?
They bisect.
Oh boy. Oh boy. We need a little.
They create.
Yeah, that's right. What do they create?
90-degree angle.
So hey, now answer my question now. Where should I have a marking? You said they create right angles, right?
Yeah.
So name an angle where there should be a right angle.
ABD.
Okay, here we go, guys. ABD should be a right angle. Now redeem yourself, Brian. Where else should I have a right angle symbol?
Angle FGD.
FGD, good. Everyone's all good there now. That's definitely should be on your diagram at the beginning here. Okay, everybody good? Okay. Next thing, take a look at the angles I'm asking you to prove congruent right now. Don't mark them. Do not mark them because that's not true. Just look at where those angles are right now, please. And see if something we've used already this year, specifically a couple days ago, how you could use the right angles and the given angles congruent to get to those two prove angles. How could you use the right angles you've already marked and the two angles that are congruent? How could you use those to show those prove angles are congruent? Something we've used already. Okay, you don't need to make anything up. Ready? That's one of the angles I need to prove congruent that I just did in yellow. What can you do with the right angle and this one to get to that angle? What can I do here? We got this. I don't want to get everybody here, but here we go. Owen, what do you have for me?
You can subtract the congruent angle from the 90-degree.
You got it. Okay. Subtraction! That's what we're saying. This is a subtraction proof. That's it. This is subtraction. Does everyone at home see that this is subtraction? We good? Okay, whoa. There's some rules we need to follow before we use subtraction. If we're going to subtract, we need how many pairs of equals? 2. How many are given? 1. So what we need to say is that the other pair are congruent. Well, what's the other pair going to be? We're going to take the right angles, and you don't have to write this down, minus the given angles. Does everyone see what we're doing right now? That's our subtraction, the right angles minus the given angles. Well, you already know the given angles are congruent. What don't we know are congruent yet? The right angles. You need to tell me that the right angles are congruent. All right, and that is your first new theorem for today, is all right angles are congruent. Okay? Everyone see our plan. We're going to say right angles minus the given angles is equal to what we need. Everyone's good. But I don't have the right angles congruent yet. Okay, so how do I get to that point? Well, everyone sees the new theorem here. All right angles are congruent. Can you guys make a note for me up here? Because you cannot use that any single time you want. There is a prerequisite for it. All right, there's a condition that needs to happen before you say right angles are congruent. Ready? You need right angles in your statements first. Okay, you need right angles in your statements first. It doesn't matter that you put them on the diagram. It's got to go. Oh boy, hopefully I didn't break that. It's got to go right here. Good? Doesn't matter it's in your diagram. You need to tell me in your statements, this is a right angle and this is a right angle. First thing, name one of the right angles again for me. 2. Quincy, let's go. What's one of the right angles?
Angle ABD.
Angle, okay, so I need to say angle ABD, and Quincy, give me the other right angle.
Angle DGF.
I need to tell you that they are right angles. Not that they're congruent yet. That's coming up. You need to first tell me that they are right angles. Yes, Kyle.
You also set them to 90 degrees. Like we say they're equal to 90 degrees. That works too.
That's fine. I'd be all right with that. Okay, so you need to tell me that they're right angles first. All right, well, what's the y part? Why are they right angles? You guys did this first day. Remember, I gave you something and you wrote down as many things as you could. You know why they're right angles. All right, you know why. Woo, go ahead, Maeve. Okay, I could go definition of perpendicular. Also, this is what I like to write, and you guys saw this on day 1. Perpendicular lines form what? Right angles. And again, Maeve, you want to put definition of perpendicular? I'm good with that. I'm not going to fight that. That's still a good reason. Okay? Now that you have written that you have right angles, what can I say about those right angles? You can now tell me they're congruent. So now in step 3, you can tell me ABD is congruent to DGF. And now here's the theorem. Why are they congruent? All right angles are congruent. But you need right angles in your statement first. Okay? Everyone at home good? All right, that was the new stuff. What was your plan to do with, what's your plan with the right angles and the given angles? What are we doing with them? We're subtracting them. Okay, we know how to do that. That's going to be step 4. Tell me what angles we're going to subtract then. Woo, here we go. Emily, tell me what angles you want to subtract.
Angle ABD.
That right angle minus, good, sorry to cut you off, angle.
ABC.
Yep, and that'll be the same, Emily, as if I subtract what?
FGE.
Yep,
FGE.
minus FGE, great job. And that's just subtraction, something we've used the last 2 days. Yeah. And then guys, don't change what we've been doing. Don't change it. After we've subtracted or even added, automatically next up is what? Substitution with our proof statement. You got it. I'm not changing anything here. I'm just adding in some certain things. And I have no idea what we're trying to prove because I covered it up. DBC, DGE. All right. Still subtraction. Okay, hey, this is still subtraction. The only ready? Here's the big difference today, even though it was subtraction. Usually, when you were given one pair and you subtracted, the second pair would come from reflexive, right? Everyone remember? Always reflexive, always. But now they're right angles instead. No reflexive, there just happen to be right angles as the second pair. Okay? Anybody want to ask anything? Because the next fact I'm going to give you is very, very similar to this. Emma, what do you got?
Oh no, I was just stretching my arm out.
Oh, all right. Yep. Hey, you got to do what you got to do in here to get ready. I like it.
Is there any reason why you can't use reflexive here?
Okay, what are you going to use it on? Well, let me put it this way, Sophia. You can write all the reflexive you want, but you're not going to use it with anything else. Like, can I just throw a random line segment DG congruent to line segment DG? Sure, but I'm never going to use it. It's still correct, but like there's no reflexive you could write that you're going to use to get those two angles congruent.
You couldn't use like BDC or something?
BD.
Oh wait, no, that require two pairs, never mind.
Okay, good. And BDC is over here. It's not even involved in the angles I need. Others? All right, so right angles are congruent. You need to have right angles in your statement first before you say they're congruent. Same thing can be said. Same can be said. That's the fade for straight angles. Straight angles. They work the same way. Kyla, go ahead.
Why do you need to write that down? I mean, I feel like it's kind of self-explanatory that right angles are 90 degrees are going to be.
Well, you think that you know that in your head, but we got to get it down on paper, right? Just like in my head, if I'm in my head, I know if I subtract these two, I get the other angle next to it, right? I just got to put it down on paper. This is what proofs are. Everything going up on your head. You know that. You just got to put names to things now, right? Like addition, subtraction, substitution. Okay, you're right. I get it. I get what's going on in your head, but now we just got to get it down on paper, organized on paper. Good. You guys know the deal. Statements, reasons. Set it up. Put your markings wherever you need it. Tim, you doing all right? Okay. Hey, those two angles that are congruent, ABF and EDC, do you know where those are? Do you know where to put your arc marks there? It's not inside that four-sided figure. Hopefully you guys know that. It's not inside. Hopefully, are we marking here? Take a look. ABF is this angle right here, not inside. Inside would be CBF. Right, watch yourself there. And then angle EDC is on the outside over here. So those are my two angles that are congruent. And I'm told that ABC and FDE are straight angles. Perfect. After you guys are writing everything down and marking your diagram, look at the two angles I need to prove congruent. CBF and FDC. Look at those angles I need to prove congruent. Locate them and see if you can come up with a plan in your head right now. How would I get those two congruent, knowing that those are straight angles and those two angles are congruent that I marked? Ooh. And remember, don't come up with anything brand new. Stick to what we've been going over. All right, it's there. Stick to what we've been using. Get halves of equal quantities out of there. No shot. There's nothing being bisected. All right. What can you do with the straight angle and this angle, ABF, to get to that angle? What can I do with the straight angle and this angle here to get to FDC? What do I have to do to the two there? They're there for a reason. They're there for a reason. Yep. 15. Will, what do you think?
You need to subtract 180 from the congruent angle.
So basically, Will's saying take your straight angle and subtract a given angle. Right? Everyone see the subtraction here. If you need a visual for the subtraction, here you go. Here's my straight angle. cover up that purple angle I have. What's left? Angle FDC. So this is subtraction. Oh, how many pairs do I need to subtract? 2, but I've only written down 1. What's the other pair I'm going to need? It's not a reflexive pair now. What are the 2 things I'm subtracting? These 2 given angles I've marked in purple with the straight angles. So you need to tell me the straight angles are congruent. Okay, everyone see that? That's my second pair, the straight angles. All right, so angle A. Oh, whoa, wait a second. Hold on. Wait. No, I'm surprised nobody's going to challenge me on this. Mr. Carlino, you said in the last proof that if we're going to say right angles are congruent, you have to tell me in your statements they're right angles. Why don't I have to tell you here that they're straight angles before I tell you they're congruent? Why not? Why not, Maeve? I already gave it to you. Silly kids. Yeah, so I can go right to saying angle ABC is congruent to FDE. All straight angles are congruent. Can I abbreviate straight ST? No. I'll get that question covered for a couple of you at home. Okay, what was my plan all along? To do what with the angles? Subtract them. Go. You got 2 pairs of equals you can subtract now. What you're going to subtract is already listed as equal. So all I need from somebody is, what are we subtracting? Oh, going deep here. Hayden, what are we subtracting? No Hayden today. All right, back to the board.
No, sorry, my mic was not working.
All right, one jab. Here we go.
ABF from ABC.
ABF from A, so angle ABC minus angle ABF, and what's the other pair I'm going to set it equal to that I'm subtracting?
Angle EDF minus angle BDC.
Okay. And that's subtraction, as we know. And then, hey, shocker, what am I putting after subtraction? Oh, you mean it really doesn't change every time? Questions, comments, any concerns? You guys feel all right? Straight angles and right angles. That's the only 2 I'm going to show you today. How we doing on the, oh, we got plenty of time, huh? Spinneroonie. Here we go, number 3. Go ahead, get yourself set up. Still going strong, Tim, or you got questions for me? You good, or you still got questions? Okay, all right, let me know. Who is he talking to? Ready to talk about this? Everyone read the Gibbons. Okay? After you read the Gibbons, did anything pop into your head that was in the Gibbons? Pretty big vocab word, huh, Radhika? Bisector, right? Pretty big. Guys, what type of proof is this? Excuse me? You saw the word bisector.
I started drifting for a second. My instinctual answer.
Halves of equal quantities. Don't even sniff addition or subtraction. Guys, you see bisectors. You're taking half of the angles. Halves of equal quantities. That's not fair. We talked about that yesterday. Doesn't matter. Everything is always fair game every single proof we do. All right? We've been talking about right angles and straight. It doesn't matter. I'll pop it in wherever I want. Okay? Just to keep you on your toes. This is halves of equal quantities. Number 2, tell me what are you taking half of? Let's go. You could have done this last night for homework. Tell me what you're taking half of. 20. Oh boy, Radhika, you're on fire today.
You're taking half of EAB.
Half of EAB. All right, so I look at the diagram. If I take half of EAB, I could call it angle 1 or angle GAB. What do you want to call it?
1.
Yeah, because that's in the proof statement. I cannot rattle you. Oh, 21 right after. Zach, here we go. I can rattle you easily. Here we go. What else? What other angle are you going to take half of? FBC. And what do you want to call that, Zach? All right, not bad. Not bad. Why can both of these guys take half? What gives them a good reason to take half? I'm not going to give anything away anymore. Quincy, why can they take half those angles?
Because they have a bisector.
Definition of a bisector. Boom! Yeah! And now, because I know EAB and FBC are equal, I can take those halves and set them equal to each other. Angle 1 congruent to angle 2. Halves of equal quantities are equal. There you go. Little review, just to keep you on your toes. Remember me, halves of equal quantities. Anybody at home, any issues? Okay, I asked you to have a calculator out. Let's get it used. Let's use it now. Swing. All right, here you go. I'm given that those two lines are perpendicular. Our angle RSU is 89 degrees. What else can I put on my diagram other than 89 degrees? Look at the Gibbons right there. Look at the Gibbons. What else can I put on my diagram here? Here you go, Owen. What else?
Oh, you can put the right angle mark on RSQ.
Yep, RSQ can get a right angle because that's what perpendicular lines do. They form right angles. Okay, before I start this, real quickly, I know it says given, but see how the directions are find? Guys, that just means do the algebra. Don't put it in statements, reasons. It doesn't say prove. Okay, all that means is just do the algebra for me. Okay, do the algebra. Sorry, you guys had to erase there. You got ahead of me. It's okay. Yes, only if it says prove. And plus, anytime we do algebra, guys, never in a statements, reasons. Never in 2 columns. Okay, just do the algebra out for me. All right, so the first question is measure of RSQ. You guys let me know. What's the measure of RSQ here? Oh, 19. Here we go. Sean. 90 degrees. Oh, honors kids. We got a little extra here now in the directions. Everyone see in the bold? Justify. Meaning, I'm about to ask Sean, why did he say 90? Because he's got to write a little reason right next to it why it was 90.
Because angle or ray SQ is perpendicular to RST, and all perpendicular lines are equal to 90 degrees. So
Form 90 degrees. So we could say definition of perpendicular. We could say perpendicular lines form right angles. Guys, I am never going to be picky with your justification as long as it makes sense. You tell me in your own words why you wrote down 90 degrees. That's what justify means. Okay? Back up your answer. All right, here we go. One doesn't make us great. Let's go to the measure of QST now. QST. And by the way, these are QSU is not a straight line. Okay? QSU, it's a little crooked there, so it's not a straight line. All right, what do you got for QSU? Oh, 23. Luke? QST.
101 or
QST. It's got to be
USD.
90 degrees again. All right, well, that's great. You got the correct answer, Luke, but you got to back yourself up in your own words.
Because they're RSQ and QST are supplementary.
Okay, he said they're supplementary. RSQ and QST are supplementary. That's fine. They're linear pairs, so they're supplementary. You can also use, again, perpendicular lines form right angles, because that was part of the perpendicular line. Guys, there's a lot of ways you could go about it, justifying. All right? I'll just keep perpendicular lines form right angles. But again, they're supplementary. They're linear pairs. Last one of the day here, TSU. $11. Anthony, TSU.
91 degrees.
Whoa, big dog, 91. Back yourself up, Anthony. Why 91?
Because angle RSU and TSU are supplementary.
Okay, that's fine with me. Anybody, I'm going to, just because I like to challenge you guys, what do we call those type of angles that are right next to each other? That are adjacent, keep going. They form a straight line, though, so that makes those adjacent angles called what? Linear pairs. And what do you know about linear pairs? Linear pairs are supplementary. But again, whatever's going to get the job done.
Could you have used definition of perpendicular for the second justification too?
Yes, you could, but not for the third. Absolutely not for the third. Okay, everybody good? Okay, homework tonight. Again, you're going to use, you got some algebra here for 7 and 8, and 6, I believe. You got algebra. Okay, and then your proofs. They're not all right angles and straight angles. I might have probably thrown halves of equal quantities in there too, so be careful. Okay, you guys at home, nice job. See some of you on Monday. Have a great weekend. Behave. Balled up in the corner of your rooms. Good job. Have a great weekend, guys.